Start this. All right. We're ready to rumble here. Yeah, you guys want to do that? Or what? You remember that? No. So much trig. I know. I like our stuff way better. Oh, here. All right. So pretty exciting, actually, right? We've covered all the material that we are going to cover, right? So there's no new material. You've seen it all on a test. So that's pretty exciting too, right? There's no new material on the final exam. You have seen all the final exam type of questions at some point throughout the term in a test, okay? And so for me, it's always kind of sad to let you guys go. I know you guys aren't sad. One more course done. But I think it's sad. So this is our final exam review. I'll put a little sad face. Here, Ethan. Okay. So for an overview, did you guys get that on? Oh. Hopefully I printed enough. We'll see. So for an overview, there's going to be 15. So for the final exam, there's going to be 15 short answers. Worth a total of 20 marks. There are 5 2-mark questions. So they're a little bit bigger. Right? And then there's 10 1-mark questions, which are just kind of really quick, breezy 1-mark questions. Okay. Then there are 9 long answer questions, and just like before in the reviews, we'll only go through the long answer questions, right? But some of these from test 1 are gonna feel like, what? That was so long ago. Let me just make sure I am not on mute. Good. I was on mute for a part of another video the other day, so not that helpful. So long answer questions. And they're worth 10 marks each. Oh. So the first long answer question, and I promised, right, there's no linear programming like we did on test 1. Remember, we had to, there's none of that, right? The first one is, see, I forgot my pile of random math stuff in my office, so I don't even have a formula sheet, but I think I'll survive. So the first question, and we'll just kind of walk through them in terms of the formula sheet, but also I like to keep them in this order on the final exam, because that way you're not trying to figure out what type of question it is and trying to solve the problem, right? So they'll be in this order, only because I find that really helpful when I'm writing tests. So the first question is on merchandising. And in a slightly different blue, I'm just going to tell you where to go to find similar problems, right? Because we've got the practice final, but those are only, that's just one version of it, right? And so you want to be able to kind of work your way around these types of problems. Oh, yeah. There. So you're going to see question 6 and question 7 on test number 1. So we've done some merchandising questions, and that's where you have to find, so if you've got the selling price, the cost, the markup, you can find the rate of the markdown, for example. You can find the rate of the markup. You can find the markup. You can find all kinds of things, right? And so the gross profit margin, those are all things that we could be solving for. And so, and we'll do that example today. And so question 2 is going to be a CVP analysis question. For that, you're going to see question 4 on test 1. Okay. Bless you. Sorry, I've got 2 versions here, I guess, and they are looking pretty similar. Anyways, they are similar. I never change the format, so don't worry. But so the CVP analysis, that's where we have to build the profit function, and then we can find things like the break-even point or the break-even output, the shutdown point, right? And so we can find all those things. And so we'll go through that example today, right? But this I'll put here to clarify as profit functions. The next question, we're going to move into simple interest, right? So there's a simple interest problem. Okay. And so here's where I got caught up. I don't remember which questions on test 2, but I'll just say see test number 2. There wasn't a lot that we could do with simple interest, right? Because we could make one payment, we could make a couple of payments, and then we either pull them to a future value or to a present value, but beyond that, there's not really much that we can do there. We can find unknown payment amounts. Okay. So then the 4th part is going to be compound interest, and to specify, you're going to be solving for some unknown payment amount. Okay. And so compound interest, oops. Solve for unknown payment amounts. That's where we're going to get to today. Okay. So I will put a little kind of block here. Today we'll go through merchandising, CVP analysis, simple interest, and compound interest. And then Tuesday, right, is next day? Yeah. Tuesday, we'll go through the next few problems. Next one you have to do is a compound interest problem that you have to solve by hand, right? We're able to solve compound interest problems on our calculator, but, well, one, it's not really worthwhile because you can just as easily just do the calculations, right? But you have to show me that you can do it by hand for number 5. So this is a compound interest problem. Compound interest by hand. And these are all C test number 2, C test number 2, so, right, just looking at your formula sheet, we're moving our way down. We've gone simple interest, compound interest, and then we flip the page, and now we're into annuities. There is going to be an annuity by hand, just like you had to do on test 3, right? So I use the test. The tests are essentially practice finals, right? Because I'm preparing you for the final exam. So 6 is an annuity by hand. C test number 3. And what I'll do is I'll post the solutions to test number 3, but we're going through it next day, so, or these problems next day, so probably won't get there. Now, trying to describe these, right? You have to do an annuity by hand, which means there's 2 more annuities. The other 2, you can just use your calculator. That'll be allowed. This next one, I definitely encourage you to use your calculator because it's one of those, you make payments, make payments, make payments, sits there, get payments, get payments, get payments. I'm going to call that a 3-part annuity. Right? So a 3-part annuity which she had on test number 3. The next question is going to be a deferred annuity. A deferred annuity. You also had on test 3, C test 3, where, okay, you've got some lump sum, usually you deposit it, it sits there until it can handle taking out payments of X amount for however long, right? And so, and then we usually have to find the time it takes for the initial amount to grow to that point, right? So then we're solving for T, and you'll find that we do the same thing in the practice final, so pretty good indication of what we do on the final. Right. And then the last long answer question is a mortgage question. Mortgage. And so we're gonna, the main part of that is making our amortization schedule. Right. Which you also did on test 3. And the total is 110, oops, I didn't write that very well. 110 marks. Any questions? No? So I don't think I pulled in, I did not. Okay. Let me just. Okay. So just like before, we're not going to go through the short answers because they're just kind of quick fire drill questions, right? I will post the solutions, so not to worry. But let's skip straight to the good stuff. Because remember, the short answers is only, I think, 20 marks, right? Out of 110, so they're not worth really paying any attention to. You're gonna know how to do them anyways, so. Okay. Practice final exam. So just like on the test that we just wrote, right, if you're using your calculator, you have to tell me what your calculator inputs are and what all of the inputs are for full marks, because otherwise how am I supposed to give you marks? I'm not going to give you marks for just the answer, right? And so your inputs have to be accurate. And all right, here we go. Remember these? Yikes, in a while. An RV dealer purchases stock for $138,423, less 39%. The dealership marks up 25% of cost for overhead and 35% of selling price for profit. During a sale, this particular model of car, I don't think it's a car, I think it's an RV. That doesn't matter, but whatever. Was advertised at $119,995. Determine the cost, the selling price, and the rate of the markdown during the sale. Right. So just to remind ourselves here, I want to find C, the selling price is S, and the rate of the markdown is the ROMDA. Okay. So here's where it would be helpful if I could find the formula sheet. There. I'll just pull them in, right? Because this is where we're stealing our formulas from. So let's just outline what we have, and then we can kind of figure it out from there. Yeah. And so we're given that, so they purchase stock less the 39%, right? So the 39% is applied to the 138,000. And so that makes the 138,000 the list price, right? Because the net price is the cost to acquire the RV, right? And so we're given that L must be 138,423, and the discount on that is 0.39. There's only one discount, right? But it wouldn't make that big of a difference if we had more than one discount, right? D1, D2, whatever. Okay, but in this case, there's only one discount. And then in the next sentence, we're told that, okay, 25% of the cost is to account for the overhead expenses, right? So remember, we use E for the overhead expenses, only because O looks like a 0 and it gets confusing, right? And so E for expenses. So we know that E is 0.25 of the cost, and 35% of the selling price for profit. So we also know that P is 0.35 S. During a sale, this particular model of RV was advertised at 119,000. That's our reduced selling price, right? And so we also are given that the reduced selling price is 119,995. And we want to find C, S, and the rate of the markdown. The key here is that the net price is the cost, right? That is the cost to the dealership. And so the net price is the cost to the dealership. So if then we know that N is L times 1 minus D, and we know L and we know D, we can solve for N. So we've got N is the 138,423 times 1 minus 0.39. I do remember seeing some illegal math on test 1. You have to solve the 1 minus 0.39 before you can multiply it, right? You don't want to go this one times this one and then subtract 0.39. That's going to give you the very wrong answer. So 1 minus 0.39 is, so N is 138,423 times 0.61. I'm showing every step so that you can refer back to it. You wouldn't have to really show this step, but times 138,423. the net price is $84,438.03. It's already to 2 decimal places, so that's nice, right? Because we are talking about money, so if it wasn't to 2 decimal places, we would have to round it properly. Okay. So C, no. I'm going to put this on a new line. Since N is C, we know C is 84,438.03. That was one of the answers that we're looking for, right? Find the cost, the selling price, and the rate of the markdown. I could have just as well, and I'm pretty sure on the final I do, just asked, what's the rate of the markdown? Right, so a little bit less help, right? But you've seen this one, and so you just have to figure out, okay, what do I know? What can I make of what I know? And then usually it's 2 or 3 steps to get there, but so now we know the cost. So looking at what we have, right? If I had to find or use the reduced selling price, for example, right? That only shows up here, right? And so I'm pretty sure that I'm going to have to use this equation probably to find the rate of the markdown and not vice versa, right? Because it needs S and the rate of the markdown. So that's telling me that looking at this, I'm going to have to first find S. So make sure you can find S, and then you can find the rate of the markdown. Right, so you can kind of get clues from your formula sheet, right, by what you're given. And I know E and I know P, which means, and I know C now because I solved for it, and I know S is C plus E plus P. Given all that, I can find S, right? So we now know, and you don't, on the final, you don't have to write these little notes. I'm just writing them for you. We now know C, E, P, so we can solve for S. Since S is C plus E plus P. Just for a second, I'm going to leave C as C because C is in E. Yikes. Hopefully you can, gets a little tricky. So I'm going to leave, so S and C, I'm going to leave as variables for now, only because I'm lazy. You're more than welcome to just plug in the values and then just have 2 S's to deal with, right? But I'm going to use E is 0.25 C plus P, which is 0.35 S. Combining like terms, right? I'm going to move that 0.35 S over to the left-hand side. And so I get S minus 0.35 S is C plus 0.25 C. Being careful to factor out that common factor on each side, right? S and C. So then we have S times 1 minus 0.35 is C times 1 plus 0.25. Okay. Which means I have 0.65 S just moving the S to the right-hand side because I think it looks nicer, but it doesn't actually matter. And then I have 1.25 C, same deal. But I know what C is, so now I'm just going to plug it in once. But you could have just as well plugged it in at the very top. Right? You'll get the same answer. So then 0.65S is 1.25 times C, which we said was 84,43803. So that times 1.25, 0.65S is 105,547.5375. Solving for S, right? I divide both sides by 0.65, so I get 105,547. Keeping all your decimal places until the end, over 0.65, bless you. But now we're way more comfortable with storing values and recalling values, right? And so keeping all your decimal places, it's not going to feel as much of a burden anymore. So then S is 162,380.8269. So in terms of money, our selling price is 162,380.83. All right. So now, that was the second thing we were asked to solve for. Last thing we have to solve for is the rate of the markdown, which we already kind of spotted here on the formula sheet, right? If we know the reduced selling price and the selling price, we can easily solve for the rate of the markdown. So let's do that. We know SR and S, so we can now solve for the rate of the markdown. Because we know that SR is S times 1 minus the rate of the markdown. The reduced selling price was $119,995. And the selling price was $162,380.83 times 1 minus the rate of the markdown. Dividing both sides by 162,380.83, 119,995 divided by 162,380.83. Showing my work here, you don't have to. You have to show where you plug in your values and how you get there, and just hope that you got it right, I guess. If you the more work you show me, the more part marks I'm able to give you, right, if it's wrong. So 162,380.83 is 1 minus the rate of the markdown, which means that 0.738972698 is 1 minus the rate of the markdown. To solve for the rate of the markdown, right, usually I just do the switcheroo, but because we've kind of done it, but not too recently, right, I'm going to add the rate of the markdown to the left-hand side, and then I'm going to subtract the 0.7389 from the right-hand side, just kind of swapping places, right? And so it's going to look like this, 0.7389 72698 plus the rate of the markdown is 1. And so the rate of the markdown is 1 minus 0.738972698, which means your rate of the markdown, 1 minus that guy, 0.261027302. Or as a percentage. So the rate of the markdown is approximately 26.1%. I would accept either of those answers, right? But rates are typically given as percentages. Any questions about that one? That was a long time ago, right? Lots happened since then. Ugh. But they're kind of fun. Well, if you like that kind of stuff. All right. But no questions about that one before we go on to the next one?
Yeah, that we've done annuities. I feel like that's self-explanatory now.
I know you guys you've seen the worst. So now going back to this stuff, it's like, well, yeah, it's different, but maybe you even prefer it. I don't know. I'll put this on a, well, how did my page breaks work out here? Put it on a new page. All right, so going through our list, right, we know that this is going to be a CVP analysis question, right? And so we're going to have to find profit functions and things like that, right? And so Walmart plans to sell 200 barbecues next week at an average cost of $278 each. Their weekly staffing expenses are $1,945. That it's gotta be more than that. They've got like 5 people working there.
The self-checkouts, man.
Yeah. No one's stocking the shelves. Yeah. I'm not sure. I'm buying it. But here we go. How much must they charge for each barbecue to break even? Okay. To know what our break-even point is, we're going to need to know our profit function, right? And so it doesn't ask for the profit function, but that's our first thing that we need to do, right? The break-even point is right where our profit is 0, right? And then we look at, okay, if they want to make a profit of $1,500, then what price do they have to charge? And then if they sell 90 barbecues at $400 each, how much profit will they have or realize? If they sell 100 barbecues through a special promotion, what's the minimum price they could charge to break even? So again, setting that profit to 0 and figuring it out. And then what market conditions would force Walmart to stop selling barbecues in the short term? That's the shutdown point, right? And that's when the C is less than or more than P. P is less than C. When the price that you can charge P is less than the cost to produce the thing. All right, so here we go. Before we can solve these problems, we need to find the profit function. So before we can solve these problems, we need to find the profit function. Which means, where did it go? Here we're using our profit function section. I'm going to write something on here so that it bumps it to the top. Oops. So these are the formulas that we have on our formula sheet. So remember, for these ones, we start down here, and then we kind of work our way through the rest of the functions and just kind of build up our profit function. And so starting with the profit is the total revenue minus the total cost. So the profit of X, remember X is the number of units sold. Profit of X is the total revenue minus the total cost. And I'll just put a note here where X is the number of units sold. We can replace the total revenue with PX, or P times X, minus the total cost, just kind of slowly building it up. We can replace the total cost with the variable cost plus the fixed cost, as long as we remember that we're subtracting both of those, right? And so we've got PX minus, and I'm going to put them in bracket, the variable cost plus the fixed cost. Because that's going to be really important that we bring that negative in on the fixed cost. Because you can't add your fixed cost. You have to take them away from your profit. And then we know that the variable cost is C, which is the cost to produce the thing, times however many units you're selling. So minus CX plus the fixed cost. Now we're going to expand and simplify. So we've got PX minus CX minus the fixed cost. Pulling out that common X, we get X times P minus C minus the fixed cost is our profit function. Okay. So we're told that the cost is $278. X for now is going to be 200, and that can change, right? If they sell 90 barbecues, right, then our X is going to change, but for now it's going to be 200. And our fixed cost is going to be the same, $19.45. So we can plug these values in and say, okay, well, my X is 200 times P. Actually, I'm going to put this on a new line. Therefore, our general profit function, and I'm doing this because later on, right, our X and our P are going to change, and so it's nice to have this general profit function that we can use. Our general profit function using C equal to 278 and the fixed cost equal to 1945, those aren't going to change, right? So our profit of X is X times P minus 278 minus 1945. Well,
What do you do with the P then?
so we are given X, but the only reason, because I kind of surveyed the scene here, and because they are going to change it, right? So X is initially 200. So for this part, we can assume X is 200. And then we want to solve for P, right? If the profit is 0. But then because I kind of had to read through these and said, oh, at this point, our X is going to change to 90. So, and P is going to be 400. So that's why I want to have this kind of bare bones profit function ready to go. It would be fine. You would just have to kind of rebuild your profit function if you didn't. Okay. So if we want this guy, A, oops, to break even, right, the profit is 0. So what we know then is that we're forcing, I'll just rewrite my profit function, you don't have to. Profit of X is X times P minus 278 minus 1945, forcing profit to be 0, and X I know is 200 until I'm told otherwise. 200 times P minus 278 minus 1945. How much must they charge which is asking you to find P. So rearranging this, we get 1945 on the right, or on the left-hand side is 200 times P minus 278. And then 1945 divided by 200 is 9.725, which is P minus 278. So plus 278. P must be 287.725. In money, 287.73. And I'll put that in.
That was so
All right, so they would have to charge 287.73 to break even. How about part B? So what if they want to make some profit? I don't know if Walmart would be okay with 1,500 in profit, presumably per week, because it was the weekly staffing expenses. I don't know. They might want a little bit more. But now, same idea, right? Instead of forcing our profit to be 0, we're going to force it to be 1,500. And then again, solve for P, right? So it's the exact same problem, just with a different profit. And so again, we know the profit of X is, 200 times P minus 278, whoops, write it properly, 278 minus 1945. Forcing that profit to be 1,500, 200 times P minus 278 minus 1945. 1,500 plus 1945, 3,445 is 200 times P minus 278 divided by 200. 17.225 is P minus 278, so P must be plus 278. 295.225, or in money, $295.23. Right. A and B are the same problem, right? The first one is just making sure that you know what it means to break even, right? You have to force your profit to be 0. For C then, this is where we're changing our X and our P. Oops, sorry. And I'm gonna just steal my general. So this is where that general profit function that we did. That the profit of X is X times P minus 278 minus 1945. You could easily just arrive back at this point, right? Using your new X and your new P. But now we're solving for the profit. Right. In fact, I'm going to move this down 1. So X is 90 now, P is 400, and we have to find the profit. So if we're forcing X to be 90, P to be 400, and then we can subtract 278 and then minus 1945. This one's even easier, right? Because all the math is on the right-hand side. Starting inside your brackets, you have 400 minus 278, and then multiply. Oh, I guess I should do it piecewise. 400 minus 278 is 122 times 90. 10,980 minus 1945. So the profit of X. And if you want to be proper, right, X is 90, so you could put profit of 90 if you wanted to. Not something that I'm looking for, but just a nice touch. Is going to be 10,098 plus 1945. 12,000 minus. I had to do it twice because 9,035. Profit is in dollars. Any questions about that one? Then let's do the next one. So now, part D. If they sell 100 barbecues through a special promotion, what's the minimum price they could charge to break even? So now we're told that X is 100. Find P. Break even is when profit is 0. This is the same question as part A, right? Just different X. So we've got, and again, I'm just going to use that general profit function that we developed. And so we've got the profit of X is X times P minus 278 minus 1945. Forcing the profit to be 0 and X to be 100, I can solve for P minus 278 minus 1945. Add 1945 to both sides. 100 times P minus 278. 1945 divided by 100. I get 19.45 is P minus 278. So P then plus 278, 297.45. And because that's already to 2 decimal places, we can say it's in dollars. Okay. Part E. What market conditions would force Walmart to stop selling barbecues in the short run? Right? If they have to stop selling barbecues, this is the shutdown point. Right? The shutdown point is when P is less than C. We know the cost is 278, and so P less than 278. Just to explain it a little bit, although this is the answer here that I'm looking for. Walmart would reach a shutdown point if the price they can sell a barbecue for is less than the cost, $278. Right, they have to spend $278 to buy this barbecue. They have to be able to sell it for at least 278, right? All right. Any questions about that one? It was a long time ago. Blast from the past, indeed. All right. You guys ready for some simple interest? They're so cute now. You'll see. see, I'll put it on a fresh page here. All right. You'll know it's simple interest because I told you that I'm not changing the order, but also the first thing you're gonna do is read the problem, of course. I took out a series of loans, $4,000 on September 4th, 2004, a loan for $10,000 on December 12th, 2004, and a final loan for $2,000 on February 13th, 2005. What total debt do I owe on June 6th of 2005? Assume that I was charged 7.5% simple interest. Right? Which means the only formulas that we're allowed to use are the simple interest formulas. Okay. So this is where we started making timelines, right? And I know you guys didn't really like them then. Maybe you still don't like timelines, right? But now we can kind of get really good at timelines. I am marking the tests, and some of these timelines need some work. So let's get a really good handle on the timeline. I'd say if I see a good timeline, I know you're going to get close to 9 out of 10, 8.5 out of 10 if something goes terribly wrong, right? So a lot kind of hinges on your timeline. You can get 6 out of 10 without a timeline, but why risk it? All right, so here we go. For our timelines here, because we've got dates, well, we're gonna have to use our days between dates on our calculator, right? And so we've got September 4th, 2004, December 12th, 2004, and February 13th, 2005. But then I also wanna know what their value is on June 6th, 2005, right? So I've got 4 dates that I wanna plot on here. Okay. I'm not gonna put today on there just because these are all dates, right? So we don't need a reference point. So that's nice. So for my timeline here, I've got 1, 2, 3, 4 points. And I'm just gonna space them evenly because it's really just to help me map out the problem. So I'm gonna put my dates on here. I've got September 4th, 2004. Remember, dates go on the top, amounts go on the bottom. I'm going to put my dates on and then put my amounts on. December 12th, 2004. February 13th, 2005. And then June 6th, 2005. Now I'm going to go through and I'm going to put my dollar amounts below each of these ticks. All right, so 4,000 goes below September 4th, 10,000 on December 12th, and 2,000 on February 13th. And then we want to know, what total debt do I owe on June 6th, 2005? So June 6th, that's where I'm interested in, right? So I have to pull all these loans forward to June 6th. Right? And so here I want to know, what's the value here? So that means, and I work my way from the closest to the date that I'm interested in and move my way out. Otherwise my arrows are all overlapping and I don't think that looks nice. So I'm going to call this future value 1. Future value 2. Future value 3. If I add those up, that's the total owing. For simple interest, right, we write down the rate somewhere. So R is 0.075, right? 7.5% simple interest.
Is that what it's asking? Is for all of them to be added up?
Yeah, because it's asking what total debt do I owe on June 6th. Okay. So for a complete timeline, right, we have to have our T on our arrows. That's going to be a little bit of work, right? So I'm just going to jot down here T1, T2, T3, and then I'm going to find that work down here. So solve for T1, bless you, T2, and T3. So we have to use the days between dates on our calculator, and I know this was kind of our first time on the calculator, right? So it was a little bit weird, but just like we do for annuities and for compound interest, right? I'm just gonna list the entries that I'm giving my calculator, right? And so date 1 is the first thing it needs, and then date 2, and the days between, days between dates, DBD. Remember, we enter it in month, dot, day, year, year. So if date 1 is September 4, oh, sorry, T1. It doesn't matter which one you do first, right? I was about to do September 4th, but just remember that that's T3, right? So you're not getting confused. But I'm going to do T1, which is February 13th, 2005. So I've got February, which is 02/13/05. And then date 2 will always be June 6th, 2005 for all of these. So that's not going to change. So 06/06/05. So when I use my days between dates here, I get 02/13/05. Enter, right? Otherwise it doesn't save. Scroll down, 06/06/05. Enter. My days between dates, to show that I've calculated this one, compute. I put a little asterisk. So it's 113 days. So I'm going to put that on here, 113 divided by 365. Right? It's been a while, but we assume 365 days in a year. To save a little bit of space here, I'm going to do another date 1, date 2, and the days between dates for T2. Date 2 is going to stay 06/06/05. But date 2, or date 1, is December 12th, 2004. So 12/12/04. So now I can just flip back up to date 1, leave date 2 alone, and flip between date 1 and the days between dates. 12.12.04, or sorry, 04. Compute. I get 176 days. So T2 is 176 over 365. And finally, just kind of keeping it, I've got a page break coming up here, so I'll just do it down here, date 1, date 2, days between dates for T3. Changing date 1 to September 4th, 2004, I've got 090404. And then 060605 stays the same. Flipping back up to date 1, I get 090404. Oops. Oh 404. Enter. I get 275 days. So then T3 is 275 out of 365. Remember, T is always in years. All right. The worst part's over. All right, finding all those days between dates. I find it actually takes longer when I'm talking through it than actually doing it. Doing it, it's pretty quick. So, all right. Our timeline is complete. So now it's just a matter of finding our future values, right? And so this is the one that we're using here. We don't have changing interest rates, and we're not finding for the solving for the amount of interest. So this is going to be your go-to formula here. So FD1 is P times 1 plus R times T. I told you these were so cute. 1 plus R times T. Da. All this victory music. Future value 1, so P is the principal amount, and for future value 1, P is 2,000 times 1 plus R, which is 0.075 for all of these, times T, which is 113 over 365 for future value 1. So 113 over 365, right? Working from inside our brackets, blooming out. I'm not going to show all these steps because it's well, I'm going to say it. Very simple math. Times 0.075 plus 1 times 2,000, which means you don't have to show your work either. 2,046.438356. Rounding to 2 decimal places though, because it's money, 2,046.44. Same deal, future value 2 is P times 1 plus RT. P for future value 2 is 10,000 times 1 plus R, which is still 0.075, times T, which is 176 days. So 176 over 365 for future value 2. So 176 divided by 365 times 0.075 plus 1 times 10,000. I get 10,361.64384. Rounding to 2 decimal places, I get 10,361.64. And last but not least, future value 3 is P times 1 plus RT. P for future value 3 is 4,000, sorry. 1 times 1 plus 0.075 times T, which is 275 over 365. And again, 275 over 365 times 0.075 plus 1 times 4,000, 4,226.027397. Rounded to 2 decimal places, 4,226.03. Going back to our timeline, right? We want to find the total owing. So we're going to add up future value 1, 2, and 3. So the total owing is future value 1 plus future value 2 plus future value 3, which is 2,046.44 plus 10,361.64 plus 4,226.03, which means our total owing, I'm going to cheat here, 16,634.11, and that's in money. And that's your answer. Took a lot longer because I'm blabbing it out. But any questions about that one?
I don't think I would have gotten past this one.
Which one do you want? Got it. Nice. Yeah, because this was so long ago, right? We have to talk it out. Kind of. Redemption round. All right. Any questions about that one? No? All right. Then let's go to the next one. And I can't remember how far I said. Question 19. Oh, before I forget, on your question, question 22, it ends with, what biweekly investments should you make over the next 20 years? It should be 23 years. And so just make sure that you change that on your handout to be 23 instead of 20. So, because I caught it after I had printed them, and I thought, I'll just tell you guys what to do. All right. So this is the last one we'll do today, and then we'll leave the rest for next day, right? But at least you'll have some time to work through them on your own a little bit before we do. You don't have to though. A contract requires payments of $3,000 and $7,000 made in 2 and 5 years respectively. What 3 equal payments made today, 6 months from today, and 1.5 years from today are equal in value to the original contract? Assume that money earns 6% compounded bi-weekly. So here, this means that I have compound interest. So on your formula sheet, and also because, right, in annuities, interest has been compounding as well, but you don't have these regular payments that you do in annuities in compound interest, right? So these are the formulas that we have to work with, right? Where N is the number of compoundings, whereas in annuities, N is the number of payments, right? So it changes slightly. So a contract requires payments of 3,000, 7,000 in 2 and 5 years respectively. We'll call that your original contract. Okay. So if we have to map out our original contract, let's do that here. So from today, right, we would make a payment in 2 and 5 years. Okay. So from today, we would make a payment at, and you know what I'm going to do? I'm going to put 2 years and 5 years. The only reason that I scooched the 2 years over is because my new payments are 6 months from today. Oh, today is 6 months from today and 1.5 years from today. So those are all going to happen before the 2 year mark. So it would be fine if you didn't kind of catch on to that, but you could evenly space them out. That's fine. Okay. But what it's saying is, okay, we're going to make payments of 3,000 at the 2 year mark and 7,000 at the 5 year mark. What 3 equal payments made today, 6 months from today, and 1.5 years from today are equal in value to the original contract? And then I tell you to use today as the focal date. Okay. What does that mean? It means that I'm going to pull all my value to today. So for this original contract, right, this 3,000 is going to get pulled back to today. And because I'm pulling it backwards, I'll call it PB1. And then the 7,000 is going to get pulled back to PB2, let's call it. And this is the, if I add these up, this is the total value of original contract today. T here is 2 years, right? The length of this arrow is 2, and T2, the length of that arrow is 5 years, right? So nothing crazy. And I'll just jot down that the rate for all of these seem to be 6% compounded biweekly. So the rate is 0.06. And the compoundings per year is 26, right, biweekly. Okay. Now I'm going to map out my new contract. Starting today again. And because I've done this problem a lot of times, I put the 2 year mark closer to the 5 year mark. You don't have to do that. But it just might help with visualizing, right? Because now we've got unknown payments today, 6 months from today, that's half a year, right? And then 1.5 years from today. So what I'm going to do is I'm going to put 0.5 years and then 1.5 years. And then they kind of line up with the 2 years and the 5 years. That's just me being picky. They don't have to. How do we denote unknown payment amounts? Because they're equal, we just use X. X, X, X. You might be tempted to use PMT, but PMT is only if you're making regular payments. So these happen to be, so this is a half a year later and then a year after that. And so that's not regular payments, right? So that's why I'm going to use X and just kind of keep PMT separate, right? Because PMT is if I'm making monthly payments or annual payments or something like that. Right? All right. So using this as my focal date again, right? That means I'm going to pull this arrow back here and this arrow back here. And this is going to be present value 3, let's call it, and present value 4. Add those up, including the X, right? We're solving for that amount, but this is the total value of the new contract today. If these things are going to be equivalent, right, we better make sure that these totals are the same, right? So that's our key to figuring these out. So on here, I've got T3 is 0.5 and T4 is 1.5. It's nice because they're just in years, so we don't have to do any work with the days between dates or anything. Oh, whichever. Yeah. I think so. How about that? It's just because now that we've used the compoundings per year, I find it's hard to kind of go back to just using F because we know later we'll have F1 and F2. But so now it's just F, or if you want to think of it as F1, it's still F1, but we don't need F2, or we don't have F2. So our first thing that we're going to do, I1, I is just R over F. Right, I'm going to get that out of the way. 0.06 over 26. 0.06 over 26. I get 0.0023076692, which I'm going to make a note that I'm storing in 1. And if you're going to use the shorthand and use the recall, whatever, you have to tell me where you stored stuff, right? Otherwise, can't just take your word for it. So our main squeeze on here, we're solving only for present values, right? So that's the formula that we're using. Present value is our future value over 1 plus I to the power of n. Ooh, I messed up, didn't I? I just put T and called it a day, but I really want n on these arrows. Oops. Good thing there's room. N1 is time times the frequency, 2 times 26. Oops. 2 times 26 is 52. And 2 is time times the frequency. 5 times 26, 130. 0.5 times 26, I'll just say n is 13, and n for 1.5 times 26 is 39. So present value 1. The future value of PB1 is 3,000 and n is 52. So 3,000 over 1 plus, and here I'm going to do recall 1 to the power of 52. I can only do that because I said what I stored in 1. 3,000, or actually I'll start with the brackets on the bottom. 1 plus recall 1 to the power of 52. And then 3,000 divided by that guy. PB1 I get is 2,661.129183. So in money we get 2,661.13. Now we do the same thing for PB2. PB2 is the future value over 1 plus I to the power of n. The future value for PB2 is 7,000 and n is 130. 7,000 over 1 plus recall 1 to the power of 130. 1 plus recall 1 to the power of 130. 7,000 divided by that. 5,187.520157. Rounded to 2 decimal places, 5,187.52. So now I know the value of the original contract. I'm going to go ahead and find PV 3 and 4 as well, right before I do any kind of solving here. These are just going to be x's that are pulled back, right? And so we're going to have something in terms of x, but that's okay. PV3 is the future value over 1 plus I to the power of n. The future value here is just x over 1 plus recall 1 to the power of 13. 1 plus recall 1 to the power of 13. X is over 1.03041892. That's technically 1 over that times x, right? So if you do 1 over that answer, that's going to bring it up to the numerator. You even have the 1 over x button, which will just do that for you. And it brings this from the denominator up to the numerator if you hit it. Either way you prefer to do it, you're going to end up with 0.970479075x. I'm going to store this in 3 because it's my present value 3. Not that it matters, it's just a way for me to try to remember. Because I'm going to need to use that entire number, right? So you want to store that.
Sorry, can you go back? What did you do to get 0.97?
So from here, right, this is the same as 1 over 1.030418892 times x. And 1 over 1.0304 is 0.97, whatever. And you can use the 1 over X button on your
So do we
calculator.
have to show that work, or can we just use the button?
No, you can just use the button, yeah. As long as you get the same answer as me, it doesn't really matter how you got there. Okay. Same thing for present value 4. Future value over 1 plus I to the power of n. Future value again is x over 1 plus recall 1 to the power of n, which is 39 for this one. 1 plus recall 1 to the power of 39. So I get x over 1.0940600838, which is the same as 0.91402593, bless you, times x, which I'm going to store in 4 in an effort to try to remember where I've stored things. So now we know the original contract must be equivalent, right? So equivalent to the new contract. So that means that present value 1 plus present value 2 has to equal x. Don't forget about that x, right? We're still making an unknown payment amount today, so we have to take that into account. Plus, and then I'm going to do recall 3, or I'll plus PV3 plus PV4. Plugging in our values, right? PV1 was 2661.13. PV2 was 5,187.52. Let me just check those. Yeah. And those have to equal x plus recall 3 times x plus recall 4 times x. Saving ourselves some writing. Because recall 3 is 0.097, blah, 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 blah. And recall 4 is 0.914 x. So now I can simplify on both sides. So I get 7,848.65 on the left-hand side. And pulling out a common x, I get x times 1 plus recall 3 plus recall 4, which is x times, or I like my coefficients out front. So 1 plus recall 3 plus recall 4, I get 2.884505.028 times x is 7,848.65. Now I'm so close I can solve for x, right? Dividing both sides by 2.88, but with all decimal places. So x is 7,848.65 divided by 2.884505.028. So x must be, so 7,848.65 divided by previous answer, 2,720.96943. These are unknown payment amounts, right? So they're in money. 2,720.97 We did it. Whew. Any questions? So we'll keep working through these next day, right? But that's it for today. Kept you long enough. Mark, good. All right. See you guys on Tuesday. Last class. Hey. That is totally fair. Hey, me too. Yeah. But I'm sad to not see you guys. See you around. Usually I teach a lot of stats. I've got Stat 121 next term. I don't have any stats this term though, so it's really weird for me. Stats is my jam, so usually that's what where I be. Yeah. Sorry guys.